Hey everyone, and welcome back to the channel. Today, we are pulling back the curtain on one of the most important, yet least talked about, shifts in the world of artificial intelligence. As a manager in this space, I often hear the same big concern from clients and developers alike. How do we build massive, hyper-intelligent models without compromising the privacy of our users? In the old days, and by old days, I mean about 5 years ago, the answer was always to centralize. You would vacuum up data from every corner of the globe, dump it into a massive data lake, and train your model there. But in a world of GDPR, high-profile data breaches, and a growing demand for digital sovereignty, that old way is becoming a huge liability. If you haven't heard the term, think of it as bringing the code to the data instead of bringing the data to the code. In a federated system, your raw data never leaves your device, be it your phone, your laptop, or even a hospital server. Instead, the model itself travels to your device. It learns from your specific patterns locally, and then it sends back a tiny, encrypted summary of what it learned, not the data itself, just the knowledge or the mathematical gradients. The central server aggregates these updates from millions of users to create a smarter global model, which is then sent back out to everyone. It is brilliant, it is private, and it is working right now at a massive scale. Let's look at some of the heavy hitters who have already proven this works. First up, let's talk about the phone in your pocket. If you use Gboard, Google's flagship keyboard, you are already a part of a massive federated network. Think about how sensitive your typing data is. It contains passwords, private messages, and medical searches. Google knew they couldn't just upload everyone's keystrokes to a cloud server to improve their next word prediction. Instead, they implemented federated learning. When your phone is idle, plugged in, and on Wi-Fi, it performs a local training pass on your recent typing history. It updates the local model's weights and sends those tiny adjustments back to Google. This is how Gboard learns new slang or trending words across the globe without ever seeing your actual private messages. From a management perspective, this reduced their infrastructure costs significantly because they weren't storing petabytes of raw text data. Apple does something very similar with Siri. When you say, "Hey Siri," the voice recognition doesn't just get better by magic. Apple uses private federated learning to refine the acoustic models. They want Siri to recognize your specific voice even in a noisy room, but they don't want your audio recordings sitting on their servers. By training locally on the device, Apple keeps the privacy promise while the assistant gets sharper with every update. But the real world-changing potential of this tech is happening in healthcare. This is a sector where data is famously siloed. One hospital might have 500 scans of a rare brain tumor, which isn't enough to train a robust AI. But if you could combine data from 50 hospitals, you'd have 25,000 scans, a goldmine for a deep learning model. The problem? Laws like HIPAA and GDPR make it almost impossible to move that sensitive patient data across borders or even between institutions. This is where companies like Oaken come in. They've successfully used federated learning to connect medical centers across the globe. Each hospital keeps its patient records behind its own firewall. The AI model travels from hospital to hospital, learning how to detect tumors or predict drug responses, and then moves on. The result is a diagnostic tool that is far more accurate than anything a single hospital could build alone, all without a single patient record ever being shared. We're even seeing this in finance. Banks are notoriously protective of their data, but they all face a common enemy: fraud. In a successful case involving several European banks, federated learning allowed these institutions to collaboratively train a fraud detection model. Normally, a bank can only see fraud patterns within its own system, but by using a federated approach, they could identify global, money laundering patterns by learning from the collective data of multiple banks. They got the benefits of a shared brain without ever exposing their individual customer identities to their competitors. So, why does this matter to you? Because we are moving into an era where data moats are being replaced by collaborative intelligence. As a manager, I see this as the ultimate win-win. We get better products, lower storage costs, and we finally stop treating user privacy as an obstacle to innovation. Federated learning proves that we don't need to know who you are to know how to serve you better. It's technical, it's complex, but it's the bridge to an AI future that we can actually trust. Thanks for watching. If you want to see a deep dive into the specific math behind secure aggregation, how we make sure those model updates can't be reverse engineered, let me know in the comments. I'll see you in the next one.